Hello everyone. In this lecture I am going to discuss about different approaches for fatigue life prediction. Like here I will discuss first about Baskin's law of fatigue life prediction, then I will discuss about Coffin law of fatigue life prediction, and apart from these things I will discuss in this lecture about mean stress correction in fatigue. So, these are the contents of today's lecture. First of all, I will discuss about different approaches of fatigue life in introduction part, then I will discuss about Baskin's law of fatigue, then I will discuss about Coffin law of fatigue, and finally I will discuss the mean stress correction in case of fatigue. So, fatigue failure approach we can broadly group into three different approaches. One is called stress life approach, or that is also sometime termed as SN approach. S represent stress, N represent number of cycle. Second one is called strain life approach or epsilon. Epsilon means strain and N means number of cycle approach. And another one is very important, that is called linear elastic fracture mechanics approach. In short, it is also called as LEFM approach. So, first of all, in stress life approach, it is the, you can say, one of the very oldest approach. This approach especially used for high cycle fatigue. You can say HCF means high cycle fatigue, where component is expected to last for more than 10 to the power 3 cycle, that you can say, where the number of cycle a component can subjected to it should more than 10 to the power 3 cycle. In some book it is written as 10 to the power 4 cycle, but we will discuss here where the high cycle fatigue means which is started from 10 to the power 3 cycle and more. This types of stress life approach is suitable when stress and strain you can say are mostly elastic in nature. So, here the whatever the stress or strain produced in the component, that is generally within a range of elastic limit, that we can say. That means you can say this stress strain behavior follows Hooke's law. So, here one thing you should keep it in mind, this stress or SN approach is not suitable for low cycle fatigue. LCF means low cycle fatigue, this you should keep it in mind. Why it is not suitable? Because in case of low cycle fatigue, where the stress level are quite high, which is generally leading to a possible local yielding. So, in case of low cycle fatigue, as the stress is generally considered as above yield stress, that is why what happens in low cycle fatigue, this stress life approach is not, you can say, suitable or applicable. This is generally used to find fatigue strength and or you can say or endurance strength of the endurance limit of the, you can say, specimen or you can say component. This stress life approach is not able to distinguish between fracture initiation and propagation phase. This you should keep it in. So, this approach, as it is very high cycle fatigue, so where generally fracture initiation and fracture propagation types of things it can't distinguish. What I am telling, understand. Then second approach, which is called strain life approach, it is generally subjected to plastic types of deformation. So, whatever the strain here, it is subjected to that strain generally you can say in plastic in nature, that is why I have written here. Here generally as the component is subjected to very high stress level, that is why what happens, high stress level in the sense it is varying from ultimate stress to, you can say, yield stress level. That is why what happens, it is subjected to very high deformation, which is generally fall in the region of plastic strain region, that you can say. This you should keep it in mind. So, strain life approach suitable where generally the strain is within a range of, you can say, plastic strain. As here the stress level is high, that is why what happens, it cannot subjected to high number of cycle. That is why it is suitable for low cycle fatigue. Low cycle fatigue means where the number of cycle you can say less than 10 to the power 3. We will consider in this course low cycle fatigue means where the number of cycle level is less than 10 to the power 3. A strain life approach generally give a good picture of crack initiation. Why? Because what happens, that it is subjected to very high deformation. That is why what happens, this can provide you a good picture of fracture initiation. What I am telling you, because here the deformation is quite high, within that deformation you can say fracture already started. So, fracture initiation picture this approach can give very clearly. So, but what happens, this strain life approach is very complicated compared to other two approach, that is called stress life approach and linear elastic fracture mechanics approach. So, you see strain life approach can predict the crack initiation, you can say crack initiation phenomena. But once it crack initiate, then what should be its residual life? Residual life means remain life. That things can be predicted with the help of linear elastic fracture mechanics approach. That is why what happens, I have written this linear elastic fracture mechanics approach generally suitable for remaining life prediction. Remaining life prediction means after initiation of the crack or during propagation time, what should be the life remains, that is called remaining life. That means in propagation phase it can clearly predict. This is the best model for crack propagation stage. That sort of things also I have written, you can see. Here one thing you should keep it in mind, in LEFM the most important factor which is called cyclic stress intensity factor. Cyclic stress intensity factor related thing in details I will discuss once I will discuss about LEFM approach in details. There I will discuss all the things. So, this cyclic stress intensity factor is the crack driver, you can say, which drive the crack propagation phenomena. That related things also I will discuss once I will discuss these topics in details in subsequent lecture. So, first of all I will discuss about Baskin's law of fatigue. In case of log-log scale, so in case of log-log scale we have seen that SN curve is in a linear form, like you see this is your log 10 number of cycle versus log 10 you can say fatigue strength. So, there what we observe that it follow some linear types of curve, you can say. Okay. So, this linear relationship in log-log scale can be represented by a power function. This linear, once you represent these things in only stress strain curve, like let us consider this is our fatigue strength and let this is the number of cycle. So, here generally this relationship you can represent by a, you can say, power function. This power function which can be represented as, like here I am showing, SF is equal to, you can say, A into n to the power B. This you should keep it in mind. But in log-log form it is a linear function. How it is, it become a linear function, that also I will show. So, you see, so this SF means fatigue strength, N is number of cycle, A and B are called constant. What is A? B is called slope, A is called intercept in log-log scale. How it is, that also I will show. This whatever the power function in case of SN curve which I am representing, that is fatigue strength equal to A into n to the power B. This is developed by a researcher whose name is Baskin. That is why this equation is also called as, here I am writing Baskin equation. What I am telling, understand? This Baskin equation generally applicable in the field of what it is called SN line, and it is generally applicable for high cycle fatigue range. This Baskin equation is mainly applicable for high cycle fatigue, where the component subjected to, you can say, elastic types of strain, this you should keep it in mind. So, how it is a in log form, how it is a linear curve, that I am going to show. If you take log form in both the side, SF into log A n to the power b, then what are the things we will get? So, log A plus b into log n. So, you can write this is actually b into log n, here the base is 10, this log base is 10. So, plus you can say log 10 a. So, in a linear equation form, what we know, in case of a linear equation form, let this is a equation. This equation, if it is represented, let this is our y axis and this is our x axis, we can represent as y equal to x plus c. What is c? C is generally known as, always you should keep it in mind, intercept. So, you see from here to here, whatever the distance, generally this is generally called c. C is called intercept, or you can say y intercept. So, in this case this c is actually what? C is log a. So, log a is called intercept. What is b? B is called the slope of this curve. Slope means, let's, this is our b, this is our 1. So, this b is called slope of this straight line, this you can say, this you should keep it in mind. So, in log form generally we can represent this Sn curve, which is a linear, this power equation is a linear function, what I am telling, understand. So, what is a and b, you got the idea, this a and b are two constant, this you should keep it in mind. So, this equation, power equation is known as Buskin equation. This Buskin equation is used to find the number of cycle, what is the number of cycle for a particular stage value, what I am telling, understand. How we can calculate this thing, that I am going to discuss now. So, first of all, so from this equation, let what happens, this equation in log form you can write like this. So, from this equation what we can write? We can write you can say log SF, which is equal to this a and b we need to find out, correct. So, how we can find out this a and b? So, you can say log SF b into log n plus log a. So, here what we can write, b we can write as log fatigue strength minus log a divided by, you can say, log n. This you should keep it in mind. So, this you can further simplify like log SF divided by a divided by log n, correct. Now, to find here two unknown is there, a and b, these two unknowns are there. So, to find out these two unknown, what are the thing required? We want two equation. So, that is why what happens in case of traditional plot, how we can find out this a and b, that I am little bit showing. Like let us see, you know this in case of traditional plot, we can find out what it is called this a and b, how, that I am showing. Traditional plot of Sn curve, which is generally represented like this, let this is the number of cycle, this is the SF. So, generally the one point we represent a line which is starting from S ultimate to what it is called S you can say this is, let us consider as yield. Then after that you can say another straight line which is varying from this S yield point to S endurance strength, After that generally in case of steel it has become a horizontal line, the asymptotic line, correct. This is the traditional purpose. For this purpose, so what we can say for this case, how to find out this A and B, that I am just showing. So, for this case let this line represent case 1, this line represent case 2. So, for line 1 here I am writing for line 1 or case 1, here you see here generally there are two what is called fatigue strength value. In one case SF is equal to S ultimate and another case SF equal to you can say S yield. Okay. So, by using this two we can get two equation. In the last slide already, what is this two equation? One equation is you can say log S ut by A divided by log n, this log n corresponding to at this what is called ultimate value, whatever the number of cycle it will be, that will be the things. This is equal to you can say B, let us this is B1 for line 1 case. Another equation is for S you can say yield strength which is in plastic region, this divided by you can say log n, let us consider. So, this will give us for this equation this B1 will be constant and there will be A1. So, by solving these two equation, let this is equation number 1 and this is equation number 2, we can get what is A1 and B1. So, for this line 1 in case of traditional purpose, generally whatever the what is called number of cycle for a particular fatigue strength value, that we can easily calculate, because by using this A1 and B1 is now known. So, our equation is now become you can say SF is equal to A1 n to the power B1, this is for equation or you can say line number 1, correct. This way generally we can easily find out what should be the fatigue strength for a particular number of cycle or what should be the number of cycle for a particular fatigue strength. This is one case. In another case like for line 2 also, in traditional purpose for line 2 what we can say, here also we can say for one case SF will be you can say SY, another case will be SF will be S endurance strength. So, by this we can easily find out what is our A2 and B2 value. So, by this in this second region generally we can easily find out what it is called, what is the value of A2 and B2. Always you should keep it in mind, generally this Buskin equation is more appropriate and it is mostly used in this high cycle fatigue zone. That means in this zone which is after yield region, after that means which is in the region of elastic zone, which is in the region of you can say elastic zone, this you should keep it in mind. This is called generally traditional way of representing Buskin equation. Okay. So, another form of this equation also we can write, that is generally you can say that is called you can say conservative types of plot. Here generally our SN curve we represent instead of two different line, here we generally represent a single line and after that a horizontal line. So, it start from ultimate strength and you see this is our endurance strength. So, this line represent let us line 3. So, for this line 3 generally we can find out conservative plot purpose also, this is general form of equation we can write. Here also in one case SF is S ultimate, another case SF is you can say S endurance strength. For that generally we can get A3 B3. So, by this also we can get a equation that is called conservative Buskin equation. This you should keep it in mind. Okay. So, this is the way generally to find out A1, B1. Based on this A, B value, we can easily find out what are the number of cycle for a particular fatigue strength, or for a particular number of cycle what should be the fatigue strength value, that we can find out. Okay. Generally this equation which I am showing, this equation generally in case of amplitude form also we can write. What is called a stress amplitude form also we can write. How? That I am going to show. So, here this stress generally in case of what it is called stress amplitude case, we can write as S A is equal to, we can write you can say this S A is equal to A into n to the power, you can say B. So, this equation further simplify by only one variable. How it is? That I am going to show by using Hooke's law, because this Buskin equation mainly applicable in elastic zone. So, here we can apply Hooke's law. So, what is Hooke's law? Hooke's law we know stress is equal to your E into epsilon. This we can write. In Hooke's law generally we know stress is directly proportional to strain, and what happens once you equate it, there is coming a constant E is called Young's modulus. So, using Hooke's law, so this Buskin equation can be written as, I am just directly showing, sigma A by E, sigma A means stress by, in case of strain form I am writing. So, is equal to, you can say, once you consider this is amplitude, then generally this A is become, always you should keep it in mind, the A is considered as fracture stress, what it is called sigma F by E, always you should keep it in mind, and this n we can write in the form of number of reversal, that is equal to your 2n to the power, you can say another constant I am writing C. This way also we can write the Buskin equation. So, this way once we write the Buskin equation, here always you should keep it in mind, here generally A is converted to sigma F by E. What I am telling this using Hooke's law, generally this equation is coming. How it is coming? That also I am just showing. Here this 2n is called number of reversal. What it is called? This 2f is called number of reversal. So, Buskin equation also can be represented like this. What is reversal means? Reversal means half cycle. Reversal you can say half cycle. So, one cycle contain two reversal. So, that is why here 2n is coming. What I am telling, understand? Where n is called number of cycle, number of full cycle. This you should keep it in mind. So, this way also we can represent the Buskin equation. So, in this case also you can say this stress amplitude by E, which is in a strain form, this you can write as a strain range in elastic region divided by 2 is equal to, you can write as sigma F by E 2n to the power C. This you should keep it in mind. This is also Buskin equation. Here why we are considering elastic strain range, here you should keep it in mind, this delta epsilon E is called elastic strain range. Elastic strain range means you can say epsilon maximum minus epsilon minimum in elastic region. This you should keep it in. This is epsilon maximum minus epsilon minimum. And elastic range amplitude means, also you know these things, amplitude means what does means, once sigma A amplitude, stress amplitude, you can say stress amplitude. The stress amplitude means you can say sigma max minus sigma min divided by 2. What I am telling, understand? That is why generally always you should keep it in mind, generally range of stress. So, if we write range of stress del sigma, this is actually you can say 2 into sigma A, this you should keep it in mind. So, range of stress or stress range equal to you can say sigma max minus, so this is actually sigma max minus sigma min, this you should keep it in mind. That is why this equation is coming, which I am showing. Let us this equation number 1, what I am telling, understand. That means sigma A by E, this is equal to this elastic strain range divided by 2 equal to you can say sigma F by E. So, this is generally called Buskin equation, where only one constant C is there, and sigma F, whatever the sigma F is there, this sigma F is known as, always you should keep it in mind, fracture stress, fracture stress. So, if we draw a plot, then what you can get here, little bit I am showing. Let us consider this is the number of cycle and this is the you can say what it is called strain amplitude. So, here generally this Buskin equation in strain and what it is called number of cycle case, you can write this Buskin equation is directly I am just writing. So, it will have a slope, this is our 1 and this is our C, okay, and it will have a intercept with epsilon value. So, that intercept is you can say sigma F by E, this you should keep it in mind, because if stress divided by Young modulus is there, this is actually become a strain value, because in Hooke's law what we know. So, epsilon you can write as sigma by E. So, in a strain form generally this equation is coming, which is generally in the region of elastic zone, this you should keep it in mind. Okay. First of all we will discuss about what is called Coffin equation, after that actually we will discuss about a problem on this Buskin and Coffin equation. So, Coffin equation generally, or this equation also sometimes called Coffin Manson equation, also it is called Coffin Manson equation, this you should keep it in mind, or Manson law. This law is valid for what it is called in plastic zone. Plastic zone means where you can say low cycle fatigue region is there. Low cycle fatigue region generally I have already told you, it is varying from you can say S ultimate zone to you can say S yield zone. So, in this zone generally it is subjected to very high deformation, which is generally, that is why what happens here, plastic deformation used to come, what it is called, plastic deformation generally occurs here, plastic deformation you can say occurs here, this you should keep it in mind. So, Coffin equation is generally applicable for what it is called low cycle fatigue zone, and this equation generally you can say mainly used for strain life approach, because strain life approach is applicable for low cycle fatigue zone, whereas stress life approach generally is applicable for high cycle fatigue zone, where generally it is subjected to elastic types of strain for Buskin equation, which I have already discussed. So, this Buskin equation also we can write in the form of what it is called strain, that is you can say range strain amplitude in plastic zone. So, plastic strain amplitude, that means range of strain divided by 2, its plastic strain amplitude, this you can write as plastic strain amplitude, this equal to you can say epsilon F into number of reversal to the power let us B. what I am telling, understand. So, what are the things here? Here epsilon f is called failure strain amplitude. What it is called? Failure strain amplitude. This word you should keep it in mind, amplitude. So, strain amplitude, you know what is strain amplitude. So, strain amplitude in plastic zone you can say epsilon max in plastic zone minus epsilon min in plastic zone divided by 2, where epsilon max p minus epsilon min p, this is called range, strain range. So, this delta epsilon p is called plastic strain range. This you should keep it in mind. Okay. So, you see this equation here, you see this only one unknown b is there, where 2n is called number of reversal, number of reversal. This you should, reversal means half cycle, reversal means half cycle. N is called number of cycle, n is called number of cycle. This you should keep it in mind. So, this is called Coffin-Manson law of fatigue. This is applicable in plastic zone or low cycle fatigue zone. This generally applicable, this is also sometimes called what is called strain life approach, epsilon n approach. This you should keep it in mind. Now, if we draw this curve in what is called number of cycle versus strain plot, what we can get? We can get a equation like this. What I am telling, understand? This equation here, this intercept with epsilon is, you can say epsilon f, which is the, you can say fracture strain amplitude. This you should keep it in mind. Epsilon f you can write a, this is a amplitude value, always you should keep it in mind, a, fracture strain amplitude. Whereas here the slope is represented as, this is 1 and this slope is here is given as b. This you should keep it in mind. So, this equation is for plastic zone, is for plastic zone, whereas in case of elastic zone, for that Baskin equation in strain number of cycle equation we have seen this. So, there I have already shown it has a slope, it has a slope. So, this is generally for elastic strain zone. So, this is actually in elastic zone. So, here this slope is c and this is 1, and here also I have shown here generally fracture stress divided by E also I have shown, correct. And what is the effect of this elastic and plastic zone curve? This zone, this line, that means for total strain purpose if we draw, then what happens, this in stress versus number of cycle, this equation become like this. This is, this line you can call as total strain zone. So, this total strain zone, for this total strain zone we can write a equation by combining this Coffin equation and Baskin equation.